So in this video, I'm going to go over the second semester review for the performance exam. Number one is Unit 8, Area and Volume, and there's going to be 3 parts to this question. So we're going to start out by doing part 1, which is find the area or volume of the shapes or solids and show our work. So I'm going to scroll up here so I have plenty of room to work. So first of all, I noticed that this is an isosceles right triangle, so that tells me that this angle is congruent with this angle. So and my area of a triangle is base times height divided by 2. This is a 45, 45, 90 triangle. And my one formula for a 45, 45, 90 triangle is the hypotenuse is equal to the leg times the square root of 2. So we're going to go ahead and work this problem, and we're going to find out what these legs are, because those are going to be our base and our height in this isosceles right triangle. So we're going to put 4 in for the hypotenuse, and we're going to solve for L. So notice I have L square root of 2, so I got to divide both sides by the square root of 2. So that means L is equal to 4 over the square root of 2. So now I'm going to multiply the base times the height and divide it by 2. So that's going to be, so when I'm trying to find the area of my triangle, it's going to be 4 over the square root of 2 times 4 over the square root of 2. And all of that's going to be divided by 2, because again, that's base times height divided by 2. So our area is going to be 16 over the square root of 4. Again, all of that divided by 2. So that's going to be 16 divided by 2, all of that divided by 2. That's going to be 8 divided by 2, which is going to give us 4. And this is going to be inches squared, because that is area. Area's answers are always going to be squared. All right, now let's look at this square over here. It's very similar to what we just did, because it too gives us an isosceles right triangle. So to find the base here, we're going to use the same thing. We're going to solve for 6 is the hypotenuse, and that's L square root of 2 again. So that's going to be 6 divided by the square root of 2 equals L. So now this time the difference is that the formula for a square is a side squared. That's equal to the area of a square. So when we're looking for the area, all we have to do is take the 6 over the square root of 2 and square it. Now when we square something like this, we square the top and the bottom. So that's going to leave us with area is equal to 36. And when we square a square root, we just get the number. So that's going to be 36 divided by 2, which is equal to 18. And again, this one is going to be centimeters squared, because again, it's area. So that's our answer right there, 18 centimeters squared. The next one is a cone, and this is on our formula sheet. Now the area of a triangle is on our formula sheet, but the area for a square is not, so you have to commit that to memory. So our next problem here is a cone, and the volume of a cone is equal to base, whoops, I don't know why I did that. Let me fix this. Yeah. Let me try this again. Volume is equal to base times height divided by 3. And remember, our base is pi r squared, because that's our base is, the area of our base is a circle. And then our height divided by 3. So all we have to do here is then take our numbers and plug them into the formula. So our pi r squared, so we've got pi, don't know why it keeps doing this today. So now we're just going to put these values into our formula. So we've got pi times 8 squared times our height, which is 12, and divide all that by 3. So when we do that, we get 256 pi, and that would be meters cubed. And again, it's meters cubed because it's volume. Now if we multiply by pi, we're going to get 804.25 meters cubed. So those are our 2 answers for our volume of our cone. So now let's look at this last one in this part A. So volume here is equal to, again, base times height divided by 3. Our base here is a square, so we're going to find the area of the square first. That's going to be 2 times 2. Our height is 6, and we're going to divide all that by 3. So that's going to give us 2 times 2 is 4 times 6 is 24 divided by 3. So that's 24 divided by 3, which means this is going to be 8 feet cubed again, because remember it's volume. And you guys need to make sure that you put the right units on these, because if you don't, you're going to miss points on the performance exam. Number 1, part B, says the volume of a rectangular prism in a right cylinder are 9,750 meters cubed. The rectangular prism has a base of 6,250 meters squared. The right cylinder has a base of 2,130 pi meters squared. Which is taller, the rectangular prism or the cylinder? So first, let's talk about the volume of each of these. So now again, remember volume, the fundamental formula for volume is base times height. Now when we talk about a prism and a cylinder, we don't divide by anything here, because these are both just base times height. So we have that the volume of each is 93,750. So I'm going to put that here for both, 93,750. And then we're going to figure out what is that equal to. So that's equal to the base times the height. So our base here of our prism, and let's go ahead and put prism here so we know what we're dealing with. And this is our cylinder here. Okay, so that's equal to our base, which is 6,250 times our height. Whereas the right cylinder has a base of 2,130 pi times the height. So what we need to do here is solve for our height, because that's what it's asking us, which is taller, the rectangular prism or the cylinder. So we're going to divide both sides by 6,250 here. And when we do that, our height for our prism is 15, and that would be meters. Over here, we're going to divide both sides by 2,130 pi. And you can actually put that in the calculator just like that. And when we do this, it tells us that the height is equal to 14. So obviously it says which is taller. Our rectangular prism is taller because it has a height of 15. So number 1, part C says a sphere gas tank has a diameter of 8 feet, which when filled with gas to provide 125,000 BTUs of energy. To the nearest 10 BTUs, how much energy does 1 cubic foot of the gas yield? Show your work. So the first thing we have to figure out is how big is this gas tank. So it says it's a sphere, and it says that its diameter is 8 feet. Well, we don't use diameter here, we use the radius. So a radius is equal to diameter divided by 2. So we're going to take 8 and divide it by 2 to get our radius. So our radius would be 4 here. So once we do that, then we can find the volume of this sphere. And the volume of a sphere is 4/3 pi r cubed. So we're going to go ahead and populate this formula. So that's going to be 4/3 pi. Our radius is 4, so that's going to be 4 cubed. So when we do this, we get 268.08 feet cubed. And we need to definitely multiply by pi here, because if we don't, we won't be able to finish the problem. And we're talking about density, because that's what this problem is. It's all about density. So density is equal to mass over volume. And I told my students that it's DMV. If you can remember the DMV, then you can remember density equals mass over volume. So it says here that our mass is 125,000. And our volume we just solved for, so that's 268 0.08. So we're going to divide our mass by our volume, and that gives us 466, sorry, 0.28, and this is BTUs. BTUs per feet cubed. Now, it says in here, show it to the nearest cubic foot. So that we're going to leave this to the nearest, wait, how much energy? To the nearest 10 BTUs. So we're going to round this. We're going to round this up to 470 because that's what it's telling us to do. BTUs per feet cubed. So that's our ultimate answer right here because we rounded it up to the nearest tenth. Now we're going to move on to number 2, which is Unit 9, which had to do with segments and equations of a circle. It says here to define each term and label the circle with the following points, segments and lines. So I'm going to go ahead and click you guys over to when I have this already filled out, and we're going to talk through my drawing. Okay, so it says define each term and label them. So the first one's our center, and our center is right here. It's number 1. In the definition of a center is a point that's equidistant from the circle. Then we have a chord, and I labeled it number 2. Remember that a chord is a segment whose endpoints are on the circle. It's right here. That's our chord number 2. Diameter is a chord that goes through the center of the circle. Again, its endpoints are on the circle, but it goes through the center of the circle. Point of tangency is this down here, number 4, because number 7 is a tangent, which is a line. If you notice down here, that's number 7, a line that intersects the circle at one point, and the point that it intersects the circle is right there at 4. Then our radius, we're going to call number 5 our radius. We actually have a couple other radii here from the center of the circle there and from the center of the circle there, but I wanted to talk about the one that's uniquely a radius. And that would be this line right here, number 5, because it goes from the center to the circle. That's a segment again. A secant is a line, and a line that intersects the circle at 2 points, and that's number 6 right here. So those are all of our terms and their definitions. Number 2, part B, says that we are going to solve for x in the following problems. And we're going to explain the difference in the process using the key vocabulary terms from part A. So first of all, I want to talk about what this is. So Wx is a tangent and Xz is a secant. So when we do this, our formula, if you recall, was that we are going to take a tangent and we're going to square it, and we're going to set that equal to the outside times the whole. Okay, so our tangent is this one right here, so that's 18 squared. We're going to set that equal to our outside, which is 9, times our whole, which is 9 plus 17x plus 10. So this is going to be 9 plus 17x plus 10. So when we do this problem, when we square the 18, we're going to get 324. We multiply, and let's go ahead and simplify this over here. So this is going to end up being 19 plus 17x. Going to simplify what's in there first. And then drop this down another level here. We're going to multiply the 9 times the 19. That gives us 171. 9 times 17x. That gives us 153. X. Then we're going to subtract the 171 from both sides. So that gives us 153 is equal to 153x. So we can see here that x is equal to 1. Now, again, you need to talk through the explanation of this, and we'll talk about that in a second, but right now we're going to go on to this other problem over here on the right. So here on the one on the right, we have 2 secants. And so when we're talking about secants, we're going to talk about outside times whole. So we're going to talk about the outside here times the whole. So we're going to say outside times whole equals outside times whole. Okay, so we got the outside times the whole. So NO times NP, so that's going to be 6 times 6 plus 12 equals, and we got X down here. So this is our outside here, and then our whole again. So we've got X, and our whole, if you notice down here, is 27. That's our whole thing. So we're going to simplify this again. So this is going to be 6 times 18 is equal to 27x. Whoops, 27x. So we're going to get 108 here is equal to 27x. Going to divide both sides by 27. So here x is equal to 4. Now I want to go ahead and go to this other page that I have and show you guys the explanation. Recall that on a performance exam, if you do not write the explanation, you're going to miss half the points. So here in this problem, it says the one on the left is a tangent and a secant, whereas the one on the right is two secants. Where there is a tangent and a secant, you square the tangent and set it equal to the outside of the secant times the whole secant. Whereas the one, when there are two secants, you multiply the outside of the secant times the whole secant and set it equal to the outside of the secant times the whole secant. So this is just an explanation of what we just did, and it's really important that you guys are able to write that out. So this is number 2, part C, and it says complete the square to find the center and radius of the circle given by the equation and explain each step. So here, when I taught my students this, I told them to group the x's in one set of parentheses and group the y's in another set of parentheses and move the constant to the other side. So that's the first thing we're going to do, is we're going to put our x squared plus 14x here, and we're going to do our y squared minus 6y here, and we're going to move that negative 6 to the other side, and to do that we're going to add it. So now our next step would be to divide this middle term by 2 and this middle term by 2, that actually the coefficient, and we're going to put down here our x and we're going to put down here our y. And remember, we're looking for a binomial squared in both of these because that's what the equation of a circle looks like. So when we divide the 14 by 2, we get 7, and it's positive 7. And recall now we have to square this. We have to square this. So we're basically going to take the 7 and square it, and we're going to put it right back up here. So 7 squared is 49. Remember, if we add the 49 to the left over here, we have to add it to the right over here. So here again, we're going to divide the negative 6 by 2, and that's going to give us negative 3. Once again, we're going to take this negative 3 and we're going to square it. That's going to give us 9, and we're going to put the 9 up here. So that's going to be plus 9. And remember, if we add it to the left, we have to add it to the right. So then when we go ahead and add these three numbers together, we actually get 64. Now recall that the equation of a circle is x minus h squared plus y minus k squared equals r squared. So it's asking us to find the center, and hopefully you remember that the center is h and k and the radius is r. So when we pull these numbers, we have to change the sign, and that's because in the original equation they have minus signs. So down here where we have a positive 7, when we pull it, it's going to be a negative 7, and here, because it is a negative 3, it's going to be a positive 3. So our center is negative 7, positive 3. And when we're looking for our radius, we have to take the square root of that number over here on the right of the equal sign, because what's there is r squared. So we have to take the square root of 64. So the answer for our radius is actually 8. Let me go back again to my in-depth explanation. So here now I've typed out everything I said. Group the x's in one set of parentheses with a blank for the last term, and the y's in another set of parentheses with blank for the third term. Move the constant to the other side of the equal sign. Then divide the middle term by 2 and put in parentheses with a constant and square it. Do the same with the middle term on the y side. Now square the numbers in the second step and add to both sides of the equal signs for both the x's and the y's. Now you have an equation for a circle and can pull the center and the radius from that equation. H and k are the center of the circle, and thus if you take the square root of r squared, you get r. Okay? So that's what you need to write out for an explanation, something of that nature. So now we're on number 3, which is unit 10, and this has to do with angles and arcs of circles. So it says name and state the measure of the central angles in circle O, arc Q, and name and state the measure of all the inscribed angles. Name and state the measure of all the arcs. Show your work, explain how you found each measure. So that's what we're going to do. We're going to work through this drawing together here. So I'm just going to start working with what I have. I notice here that this is a right angle, so that means that this arc has to be 90 degrees. I also notice that this right here is 56. Now, if this is 90, then this up here also has to be 90, this whole thing right here, this whole arc. So the way that I could find ST is to subtract 56 from 90. So that means arc ST is 34. And again, this angle right here would be 90 because the arc out there is 90. So down here we have that, notice here again we have half the circle here. Hopefully all of y'all can see that. So to find this arc right here, we're just going to subtract 148 from 180, and that means this arc right here is 32 degrees. Which also means this angle right here is 32 degrees. This angle in here is 148 degrees. And recall that angles are equal to central arcs, and central arcs are arcs that vertex is at the center of the circle. Now I want to talk about these other two angles we have here. So we have this angle right here. Oops, right here. Notice that it is subtended by arc that's 56 degrees, so we can divide that 56 by 2, and when we do that, we're going to get 28 down here. So this is 28 degrees here. And then this one as well right here is subtended by the 32 degrees, so this one right here is going to be 32 divided by 2, which is 16 degrees. I'm trying to see what else we got. So yeah, I think that's everything in here. So then if we start talking about our central angles, actually let me just hold right here and we're going to go to my other drawing. So here we have our central angle VQU. So if we look at VQU, that's 148. Then we have VQW, VQW, that one was 32. Then we have WQT, which was 90, and we have UQT, and that was also 90. When we're talking about inscribed angles, we have two of them. We have VUW, and that's half of 32, so that's just 16 down here. And then we have WUS, which is half of 56, so that's 28 down here. So those are all of our angles in our arcs. And if you notice, I have a description down here that says semicircle is 180 and a right angle is 90. Central angles are equal to arcs. And the arcs are equal to the central angles. Inscribed angles are half of the intercepted arcs. Very important that you guys, again, write that out when you are answering the question. Now we're going to talk about 3B. Using the drawing to answer the questions about the circle R with a radius of 7 centimeters, show all your work, explain how you found the area of the sector UST and the length of arc TU. So we're looking for the area of sector UST. So that means we're looking for all of this out here. So it's important that you guys understand that because we're going to have to find out what that arc is, UST. So that's the first thing we're going to do, is we're going to find out what the arc is for UST. And so to do that, we're going to do 360 minus the 62, and that's 298. Now, if you recall, the formula for the area of a sector is pi r squared theta over 360. So we're going to go ahead and put our numbers into that formula. So we're going to get pi times 7 squared times theta, which in this case is going to be 298. Going to divide all of that by 360. So our answer here is going to be 40.6 pi. Again, this will be centimeters squared because it is area. And if they wanted our answer in just centimeters squared without pi in the answer, it would be 127.4 centimeters squared. Okay, then when we talk about the arc length of TU, we're talking about this right here. So we are this time going to use the formula 2 pi r theta over 360. And our theta this time is 62. So we're going to multiply pi times 2 times, 7 times 62. And then we're going to divide all that by 360 again. So we get, when we multiply this out, 2.41 pi. And this time it's just centimeters because we're just talking about a length. And if we were to multiply by that pi, the answer is 7.6 centimeters. Here again, I wrote out why I did what I did, and you could do this as you're working the problem. Use the radius, which is 7, in the major arc TSU, which is 360 minus 62. In the formula, pi r theta over 360, find the area of a sector, and then plug in the values. Same thing down below. Use the radius, which is 7, in the central angle TRU, which is 62 in the formula. Find the area of the sector. So this is number 3, part C. Let me put the 3 here. So we're going to use the drawing to solve for x and y, and we're going to show all our work and explain how we solve for x and y. If you recall here, this is a quadrilateral that is inscribed inside a circle. So when we do this, we know that opposite angles are supplementary. So when I add those two together, it equals 180. And when I add these two opposite angles together, it equals 180. So here again, I'm going to skip over to where I did my work. Actually, you know what? I'll do it here. So we're going to do 12x minus 5 plus 9x minus 2 equals 180. And then I'm going to get 21x minus 7 equals 180. Going to add the 7 to both sides, so that's 21x equals 187. So x is equal to 8.9. Then we're going to do our y. Here again, same thing, 9y plus 16 plus 7y minus 12 equals 180. Going to combine our like terms. The 9 and the 7 is 16y plus 16 minus 12 is 4. So then we're going to subtract 4 from both sides. So 16y is equal to 176. Divide both sides by the 16. So y is equal to 11. Going to go to our explanation again. So here again with part C, I just said opposite angles in a quadrilateral that is inscribed in a circle are supplementary, which means that when added, they equal 180. So now we're on number 4, which is unit 11, coordinate geometry. This one says for part A, determine the point that is 2/3 the distance from the endpoint 2,9 of the segment with the endpoints 2,9 and negative 4, 6. So on this one, if you recall, this is going to be equal to A over A plus B. Because it's the fraction form of the equation. This will be our x1, y1, and our x2, y2. Our formula was x1 plus a over a plus b, x2 minus, x1, that's our x value, and then y1 plus a over a plus b, y2 minus y1. So that's what we're going to plug into the formula here. So that means we got our 2 plus 2/3 of negative 4 minus 2. That's our x value. Our y value is 9 plus 2/3 of 6 minus 9. So let's go ahead and simplify this now. It's going to be 2 plus 2/3 of negative 6. It's going to be 9 plus 2/3 of negative 3. So when we do this, you can put this in the calculator and take 2/3 of negative 6, or you can just multiply across the top and divide by what's on the bottom. So this is going to end up being 2 minus 4. And this is going to end up being 9 minus 2. So our answer here is going to be negative 2, comma 7. And again, this is a directed line segment. This formula is on the formula sheet. The first one is when it's in a ratio. The second one, which is this one, is the one when we're given it in fraction form. So I'm going to go ahead and use my explanation up here for this question. So this one says for part B, why is quadrilateral ABCD a rectangle? So what we have to do first is compare opposite sides. Now when I do this, I tend to like to draw what I'm given. So it's got A, B, C, D. And I do that because then it helps me orient which sides are opposite. So I know that side AB here is opposite CD. So I'm going to compare those, and then I'm going to compare this pair of sides, AD and BC. So I did that using the distance formula, which is on your formula sheet. And the distance formula, just in case you don't remember, is x2 minus x1 squared plus y2 minus y1 squared. Take the square root of all of that. So when I do that, I get the length of 10 for AB, and I get the length of 10 for CD. So I know that these opposite sides here, AB and CD, are congruent. And then I find BC and AD, and when I do that, I find out that they're both 5. So this is 5 and this is 5. Then the next thing, so when I say that opposite sides are congruent, I can say that this is a parallelogram. Then the next thing we need to do is compare the diagonals. So when we do that, we're talking about AC right here and BD. So when we do that, if we find the length of them and we compare them, we're talking about, again, AC and BD here. So when we do that, we get 5 radical 5 here, and we simplify it. Or you can actually just stop right here, because you can see that this is a square root of 125, and this is a square root of 125, which means the length of AC and BD are the same length. So if AC is equal to BD, they're diagonals, and if diagonals are congruent, then we could say it's a rectangle. Okay, so let's move on to our next one here. Let me go ahead and erase this. So the next one is, what about quadrilateral EFGH? Is it a rhombus? So on this one, again, I'm going to go ahead and draw my shape here so we can talk about it. And it's asked me if it's a rhombus, so I'm going to draw it kind of like a rhombus, which would essentially be a square, maybe, if the diagonals are congruent too, but we won't go there right yet. So this is E, F, G, and H. So again, we're going to compare EF to GH, those are opposite sides, and we're going to compare EH to FG, because those are opposite sides. So when I do that, I find out that all 4 of them are the square root of 17, which means EF is equal to GH is equal to FH is equal to, FG is equal to EH. So all 4 sides are congruent, so we can say it's a rhombus. Now, to determine whether this is actually a square or not, we also need to compare, again, the diagonals. So we're talking about EG here, and we're talking about FH or HF. Doesn't really matter which way we do it. So when we do these two, notice here that we do not get the same number. So EG is the square root of 50, and FH is the square root of 18. So because EG does not equal FH, the diagonals are not congruent, and it's not a rectangle. Thus, this is just simply a rhombus. Now our last one says, why is quadrilateral JKLM a square? Okay, so here again, we're going to draw it. JKLM. So here again, we're going to compare opposite sides. So we're going to compare JK to ML, and we're going to compare JM to KL. When we do that, we find out that, again, all 4 sides are the same length. And we can, again, end here with the square root of 18, and we can see then that all 4 sides are congruent. So I'm going to put tick marks on all 4 sides. That tells me that this shape is a rhombus. Then we need to compare the diagonals, because if it's a rhombus and it's a rectangle, then we know it's a square. So we're going to compare those diagonals right there. And so we're talking about JL and KM. And when we did that, we got that JL was 6 and KM was 6. So if JL is equal to KM, then the diagonals are congruent, so it's a rectangle. Thus, because it's both a rhombus and a rectangle, it's a square. So for number 4, part C, we're given an equation, 5x plus 3y is equal to 15, and it says find the line that's parallel through the point 3, negative 3, and the perpendicular line through the point 10, 7. So here, first thing I want to do is put this in the format y equals mx plus b. So that's the first thing we're going to do. So we're going to take this 5x plus 3y equals 15. We're going to move this 5x to the other side, so that's 3y equals negative 5x plus 15. I'm going to divide everything by 3. So that gives me y equals negative 5 thirds x plus 5. Now the number that we're really interested in here is this m right here, because that is what enables me to know what the slope is of this line. So m is equal to negative 5 thirds. So we're going to use that to find the parallel line through the given point. So the given point through the parallel one is 3, negative 3. So we're going to put this in for x and y into the equation y equals mx plus b. So that means we've got negative 3 is equal to negative 5/3, that's our slope, times 3 plus b. And this will enable us to solve for b and then plug the slope m and b back into the equation so we can write it. So here, negative 5/3 times 3 is negative 5. So negative 3 is equal to negative 5 plus b. Now, we're going to add 5 to both sides to get rid of that negative 5. So that's going to give us 2 here is equal to b. Now, this is going to enable us to write the equation. So we're going to say y is equal to negative 5/3 x. That was our original slope. So it's our parallel slope plus our new b, which is 2. So this is the equation of the line that is parallel to the given line through the point 3, negative 3. Now over here, we're going to solve for the other line that's perpendicular. Okay, so we know that the perpendicular slope is a negative reciprocal of the given slope. So we got to flip this, turn it into 3/5. And we're going to change the sign. It was negative, so now it becomes positive. So that's what we're going to use. And this time we're going to use this point. And again, we're going to put in our x and our y into the equation y equals mx plus b and solve for b. So we're going to go 7 equals 10 times 3/5 plus b. So 3 times 10 is 30, divided by 5 is 6. So this is 7 equals 6 plus b. We're going to subtract that 6 from both sides. So b here is equal to 1. So our equation for this one is y is equal to 3/5. Remember, we're keeping our perpendicular slope, x plus 1. So this is our perpendicular line through the point 10, 7. So now we're on number 5, which is Unit 12, the statistics. So first it gives us some background information. A bag contains 8 black marbles, 6 green marbles, 10 red marbles, where 3 of the black marbles have white stripes, 4 of the green marbles have white stripes, and 6 of the red marbles have white stripes. So it tells us in Part A to find the probability of picking a green marble, keeping it, then picking a red marble. It says, do not take into account the white stripes for this one. Tell if it's dependent or independent. So the very first thing I need to do is count the total number of marbles. So that's what we're going to do first. We're going to add 8 plus 6 plus 10, and that's 24. Then we're going to look at the green marbles. So it says there's 6 green marbles here. So that's 6 out of 24. And it says the and word here. And when it says and, we're going to multiply. It also says that we're keeping it. So because we're keeping it, we know that this is a dependent problem, which means our numbers are going to change in our denominator. And sometimes in our numerator, but in this case, we're talking about a green marble and then we're talking about a red marble. So our numerator is not going to change, just our denominator is going to change. So we saw that we had 6 green marbles and we have 10 red marbles. So we're going to add our 10 over, multiply. I don't know why I said add. We're going to multiply 10 over 23. And the reason this is 23 is because we kept the original marble. So then we're going to multiply across the top and across the bottom. When we multiply across the top, we're going to get 60. We multiply across the bottom, we're going to get 552. And then we're going to reduce that. Which remember, in your calculator, you can do this. All of y'all pretty much know how to do that at this point. So that's our probability of picking a green marble, keeping it, and then picking a red marble. So here you'll see again that I wrote out the description. It's dependent because once the green marble was picked, it was kept and not returned, thus changing the number of marbles left in the bag. I talked about counting all the marbles, finding the probability of picking a green marble by putting the number of green marbles over the total marbles. Find the probability of picking a red by putting it over the number of the red marbles over the total minus 1, which would be 24 minus 1, which is 23, because the marble was not replaced but kept, and then multiplying the two fractions across the top and bottom and then simplifying. So that's what I mean by writing out a description when you have to do so. For number 5, part B, it says find the probability that a marble with white stripes is also red. Explain your steps in detail. So this time it says, again, we got to talk about finding the probability that a marble with white stripes is also red. So we have to figure out how many had white stripes. So when we go back up here, let me scroll back up here to the white stripes. So we had 3 of the black marbles have white stripes, 4 of the green marbles have white stripes, and 6 of the red marbles. So we're going to add 3 plus 4 plus, what was that, 6? 3 plus 4 plus 6. So we're going to do that first. So we're going to go 3 plus 4 plus 6. And that's 13. So that's the total number of marbles we have. And then it asks us how many were red of those marbles. So there were 6 of them were red. So this one's pretty easy because it's just 6 over 13. Because again, we were told that they had white stripes. So this is a conditional probability because they had white stripes and then 6 of the ones that had white stripes were red. So here again, let me go to my explanation. So I said this was conditional probability, red and white striped over white stripes. Find the number of red marbles that with white stripes. The white stripes is the conditional part, and so that number total goes on the bottom, and then the number of the red ones that have white stripes on the top. So 5C is our final problem. It says find the probability of green or white stripes. I'm going to close that. So when we talk about green or white stripes, it asks us if this is mutually exclusive or inclusive, tell why, and explain your steps in detail. So first of all, we need to go back up here and we need to look at green. We know again that our total was 24. So we have 6 green. And then the number that had stripes was 13. We just found that out on the last problem. So that's 13 over 24. And then we need to figure out how many of the green had white stripes. So that's 4. So that's what we're going to subtract. So remember, we're talking about how many were green? That's the 6 over 24. How many were white? That was 13 over 24. And then how many were both green and white stripes? That's what we're always going to subtract, is the overlap. So when we do this, we get 15 over 24. And we can reduce that to be 5/8. So here again, let's go back to our explanation so you guys can know what to write. So I said that this is inclusive because there are green marbles with white stripes. We're going to find the probability of picking a green marble by putting the green marbles over the total, then finding the probability of marbles with white stripes by adding up all the marbles with white stripes and putting that number over the total, then finding the probability of pulling a green marble with white stripes, and there were 4 of those. And so the green marbles with white stripes, again, over the total of the marbles. And then we're going to add the probability of picking a green marble to the probability of picking a striped marble, and then subtract the probability of pulling a green striped marble. So that's my explanation. Hopefully this helped you guys. Good luck on the performance exam.